This is a short introduction to the PRM-in-XML documentation tool. This tool is intended for generating documentation for RISC OS components. For the purposes of this video, you will need access to a RISC OS system to generate documentation. A prior video has described how you use the tool on Mac OS or Linux. The first thing we need to do is to obtain a copy of the PRM-in-XML tool. This can be found on GitHub, so let's go get it. I'm going to do this on Mac OS, but you can download this in whatever manner you like. We want to go to the repository, which is at https://github.com/jerf/riscos PRM-in-XML-tool. Here you can see all the sources that were used to build it, and some of the example documentation is in here. This checks how the features work. However, we just want the latest release version, so we go to Releases, and we can see in here that there is the latest release, a 1.03 version. If we scroll down, we can also see that there are example documentation that has been generated as well. I'm going to download the RISC OS version here, and that will just take a moment or two to download. There we go. Right. I now need to move it to my RISC OS system. So I need to move it from the downloads directory, from RISC OS PRM, there we go, into Documents, Windows. This is just where I happen to have stored my RPCMU. Hostfs PRM-in-XML. There we go, that's where I'm going to put it. Right, now we go over to RISC OS so that we can extract the archive. You should decompress the archive in whatever tool you like. I'm going to use the tools that are provided by RISC OS Select. I've got a directory here called PRM-in-XML, which we can see the archive has turned up in. And we want to extract it. So open a task window and select this directory. If I have a look in here, I can see the file. I want to unzip it, mini unzip RISC OS tab. There we go. That will take a moment or two, and then we can check. Yep, that looks like it's extracted some files. There are a few tools in the tools.xml directory, so we can have a look in there, tools.xml. These tools can be copied into your library, just somewhere that you can run them from, but I'm just going to use them here. And the easiest way for me to do that is to use the library command, so litlib tools.xml. And once I've done that, I can now run the RISC OS PRM-in-XML tool and generate some help. There we go. And you can see there's a lot of help provided in this about how the tool works. As we scroll further down, you can see there's example commands that you can use. Having obtained the tool, we can now create a new document. For simplicity, I'm just going to document a single SWI call. Usually you'd be documenting more than that, but you should find it relatively easy to expand from there. The first thing to do is to create a new skeleton document. Starting from a skeleton is much easier than creating a document from scratch. To do that, we do RISC OS PRM-in-XML -f for the format, skeleton. And the output file is myswi/xml. So this will generate a new file, myswi.xml, which has examples in it which you can change to create your own documentation. It also shows you a command just here where you can see what you should use to generate the documentation. So let's load up the file and see what we have. So we can go over here and load the file. So here we are. I'm using Zap, but you can use whatever editor you like. I just happen to know Zap quite well, or I did. I'm going to skim through the sections in the document, and I'm going to delete the sections that we don't need. There's only a few that we need to edit for this demonstration. You should examine them and change what you need at your leisure. The first thing we need to include is the chapter title. As I'm only documenting a single SWI call, OSWrite0, I'm going to just give it the title Writing Messages. Normally, you'd name the title after a module or the functionality you're describing. So let's change the title to Writing Messages. There's usually an introduction in the chapter which includes some words about what the module is or the area it is documenting. I'll just write an example sentence here and you can probably explain more in a real document. So go to here and we'll type in RISC OS you can print messages with different SWI calls. OSWrite0 is one example. Okay, we'll just fix the small mistake I made there, and we can go and get rid of the section we don't need. So we don't need that. Cut that out. Okay, don't do it that way. I've been using other editors for far too long. Edit, cut. Right. So there are other sections here that we are not going to need. So these can all be deleted. So this subsection here, this subsection, examples of categories and items, they're all able to go. So we should delete those. Right. There's also some additional sections here, an overview, some terminology, some technical details. You'd usually fill these in with specific details about what you were describing. We don't need them for this document, so let's get rid of those as well. We also don't need VDU codes. I'm not going to try documenting any in there. We're not going to document any system variables. We're not documenting any service calls either. Here we are. This is the SWI call section. So those bits are all gone, and we've just got the SWI calls. So let's remove the boilerplate that we don't need. And now we can start documenting it. Okay. We can fill in the details for the SWI definition. If you've got more than one SWI you wish to document, you might want to copy this template a few times so that you can fill in the details in each of them. I'm only going to document one, so I don't need to do that. So the first thing to do is to write what the name should be. So I want OSWrite0. And I happen to know, because I looked it up, that the SWI number is hex number 2. We need to describe what it does. So let's see, what does write0 do? It prints a zero terminated string. Zero terminated message to the VDU stream. Okay. Here we can define what the IRQ and FIQ state are. These are usually undefined for IRQs, and FIQs are almost always enabled. We can describe what the processor mode is. For SWIs, this will always be SVC mode. And we can state whether the SWI call is reentrant or not. Because it's OSWrite0, we know that this is actually reentrant, so we can change this to yes. Next, we have the registers that are set on entry, the values that you pass to the SWI. There's only one register passed to OSWrite0, and that's R0, and it is the string that you want to print. So I'm going to update that. So we change the register number to be register number 0, and change the text. I deleted the closing bracket there. Let's change that. So this is the pointer to zero terminated string to write. Okay. And the registers on exit are just as important. OSWrite0 returns a pointer to the byte after the terminator. The example we've got here includes a value table that describes some additional values. We don't need that, so we can go and delete it in a moment. So let's document this. Pointer to the byte after the terminator. Close the register use block. So we can now delete this value table and the redundant register use. Cut. Okay. The use section describes what the SWI call does. You should be as descriptive as you need to for the interface. That might mean you need to write a lot of words. It might mean you don't need to write a lot. It really depends on what the SWI call is or the interface you're documenting. If there is detail that is more general, it should go in the technical details section. But here, we just want to say what the call does so people know how to use it. So let's have a go at that. Okay. Delete what we have here. This SWI will write supplied string to the output stream via the WRCHV vector. There we go. One small typo. There we go. Right. Sometimes the interface will need to be extended or bugs will be fixed. The compatibility section here allows us to describe these changes together with what version of the system or the module they apply to. We don't need it here because this has worked exactly the same in all versions of RISC OS. So we can delete that. Oops. Cut. All right. There's also a related section here which allows us to document other interfaces that are related to this. If we were documenting this properly, we might include OSWrite-N, OSWrite-C, and maybe WRTV as well. But we don't need it here. I'm just going to leave it because it doesn't actually serve any need to be removed. So following down here, there are some more sections that we don't need. In this case, we've got software vectors and some others. So I'm just going to delete those because we won't need them. So the software vectors here. This is another vector example. Upcalls, entry points, some error messages, WIMP messages, toolbox methods, toolbox events, star commands, and some extended examples. So they can all go, edit, cut. So at the very bottom of the document, there's a section for metadata. This is intended for giving you additional information about what has happened to the document itself. It might not seem that important, but it's really useful to know what's changed. And it's particularly important if people are going to have to download different versions of the documentation. They'll need to know which one they've got and whether it's been updated. So it's sometimes useful to have this here. I'm just going to fill in some details to make it look sensible here. So we've got the maintainer's name. So I'm going to give my own name here, Jeff, and my email address, Jeff at jeff.org. And there's a copyright disclaimer. It is always useful to include some copyright just to help identify who the documentation belongs to. It isn't strictly necessary given you've given your maintainer's name, and the documentation will have come from you, but it is good to be clear about it. The revisions here allow us to describe each of the individual changes. As you add new changes, you'd add a new revision section. So here we go, we'll add one for this one. So this is by me. The date today is the 9th of September 2023. This is the initial version. And what did I do? Well, I created it. Created document or presentation. There we go. And at the end there's also some additional related links. So if you've got other documentation or there's things online that you need to reference, you can link the entire document to that. We don't need it here, so I'm just going to delete it. Okay. So now we have a document. We can save it. I'll save that, F3, return. And we can see if we can create something for the presentation. So if we return back to the terminal here, right? Oh, no, not that terminal. If we return back to the task window terminal, sorry, we can run the generation command. Let's try that again. RISC OS PRM-in-XML -f HTML5 output mysy/HTML mysy/XML. So that's the output file and the input file specified. So we'll run that, and if it's all been edited correctly and there's no errors, SQL, yep, that's quite right. That was not the file I meant. If we enter the file names properly and we've edited it correctly, it should tell us that it has generated the file. It's processing it. And there we go. All right, so we now have a document. We just have a look in here. We can see mysy and HTML. We can load this into the editor, and we can see, well, that looks like some HTML. Scroll down and get to the bottom and see what it looks like. Yeah, there's a lot of stuff in here. Yeah, that's still CSS code. Oh, yeah, that looks like some HTML that might be related. I can see print 0 terminated message. So let's go and launch it into a browser. I don't have a RISC OS browser on this system. It's very cut down. But let us launch one in here. So open -a into Google Chrome /documents Windows applications RPCW postfs PRM-in-XML, and the file was called mysy.html, and it's got FAF on the end of it, but that's fine. Let's go and launch that. Ah, yes, because it's got FAF on the end, it's not okay. Let's just fix that, shall we? Copy. There we go. A little tweak there. There we are. Right, so this is the content. You can see it's got some text with my typos in it, and many typos in it apparently. There's the example output and metadata at the bottom. So that's how it works. I hope that'll make things relatively easy for you to create new documentation. There are a lot more examples of the PRM-in-XML documentation on GitHub. If you search for the topic PRM-in-XML, you should be able to find them. So that's at https://github.com/topics/PRM-in-XML. And this will include a number of different repositories that have all got examples in them. I hope this helps you to produce some useful documentation.